For our respiratory lab, we're going to look at 4 lung volumes and 4 lung capacities, and we're going to use an instrument called a spirometer to do this. So we have these 4 basic lung volumes that we can measure very easily, one of which is called the tidal volume, and this is just the amount that we breathe in and out normally, the amount of air we inhale and exhale on a single round during eupnea, or quiet breathing, and it's typically about 500 milliliters. Now notice that we don't typically inhale to our maximum capacity, nor do we exhale all the air that we could possibly get out of our lungs. So we usually are occupying a volume of lungs between 22 and 2700 milliliters when we're doing this quiet breathing or eupnea. That is to say that we have about 2200 milliliters in our lungs at the bottom of every respiration, so in tidal breathing. And then we have another 22, 23, 500 milliliters above and beyond what we would reach at the top of our tidal breathing. Now let's just say that we wanted to take the largest breath that we could possibly take. And then we would fill our lungs to the maximum capacity. This is what we call the inspiratory reserve volume. So it's the top of our breath during tidal breathing plus whatever extra we can take in. By the same token, let's just say we wanted to exhale the maximal amount of air that we could possibly get out of our lungs. This would be what's called the expiratory reserve volume. So this is the amount of air below and beyond which we would have exhaled on normal tidal breathing. So it's about 1 liter. And then we have what's called the residual volume. And this is the amount of air that's in the lungs regardless of what we do. We can't get rid of it. We can't exhale it. It's just there all the time. Now, in certain circumstances where someone's had a collapsed lung or a pneumothorax or something like that, then some of this air can leave, but you would still have the minimal volume of anywhere between 30 to 120 milliliters. You would never see this in a normal patient unless the person has a pneumothorax or something like that. So our 4 volumes then are our tidal volume, whatever we can inhale above and beyond the peak of our tidal volume to fill our entire lungs. This would be our inspiratory reserve volume. And whatever we could exhale below and beyond the bottom of our tidal volume until we can't exhale any further. And this usually leaves us a residual volume of about 1200 milliliters, but this bit that we can exhale below our tidal volume is called the expiratory reserve volume. So when we look at the inspiratory reserve volume plus the tidal volume plus the expiratory reserve volume, we call this the vital capacity. So this is basically going to be the addition of these 3 volumes because it is what you can move in and out of your lungs maximally. If we add simply the tidal volume, what we could inhale on a tidal volume plus our inspiratory reserve volume, this is called the inspiratory capacity. If we basically add the residual volume with our expiratory reserve volume, we get what's called the functional residual capacity, because it's what we still have left in our lungs when we're at the bottom of our quiet breathing. So if we add all of the volumes in the lung, then we get the total lung capacity, which makes sense because it accounts for all the volume in our lungs. So these are the basic capacities and the basic volumes, and they do vary from one individual to another. And so they typically estimate that males have around 6 liters of total lung volume, adult males, and adult females, depending on the size, anywhere from 42 to 4,500, sometimes more, sometimes 500 milliliters. It just depends on the person and how big the person is. But these are basically the volumes and capacities that we will be studying. Now, volumes are fairly easy to measure, except for the residual volume. That's not as easy to measure. But the capacities, we can simply garner from adding the volumes together.